All right, hello everyone, and welcome to our class online. So let's see how this works out. So today we're going to talk about correlations. And correlations are simply the linear relationship between two variables. But first, let's talk about where we're heading in the class. There's a good spot to hide this, maybe under here. Okay, so today we're talking about correlations. This is chapter 8 in your textbook. In some ways, this is a lot easier than factorial ANOVAs, whether within or between participant, because they got quite complex. Correlation is pretty simple. It's more akin to a t-test. Although there are some things with correlations that SPSS will not do for you, and those we will have to do by hand. So that's going to involve some math. So next week we'll have a tutorial if you need any help with the correlation assignment, and we'll do that on Zoom just like last time, so I'll send out an invite for that. The Tuesday following that tutorial, the correlation assignment will be due, and Wednesday we'll actually meet on Zoom again for our last class. This is going to have kind of a few topics kind of put together. We're going to talk about researcher degrees of freedom, and on Blackboard there will be a paper to read as well as a YouTube video from last week tonight. That's kind of a popular culture version of that paper. We're going to talk about the style of your results section. So far we've been writing them in one style. I don't know whether it has a name, but we're going to look at different options and different styles you might like to use or that you'll encounter when you read research. And finally, we'll talk about the capstone assignment. So today we're going to talk about bivariate correlation, or what you may know better as Pearson's correlation coefficient. We're going to look at an example. That's what we'll cover in this first part of this YouTube series. We're going to look at the relationship between unexcused absences and attendance, and this is actual data that I got from my undergraduate class. We'll talk about how correlation does not imply causation, and I'm sure that's been emphasized heavily in any sort of undergraduate research class you took. We'll just re-emphasize that, and we'll look at some unique aspects to it. We'll look at the assumptions that are made when we make correlation. So we've looked at the assumptions of t-tests. We've looked at the assumptions of ANOVA. Many of those are going to reoccur for correlation. This is when we'll actually see the use of biserial and point biserial correlations, which are special correlations when you violate some of the assumptions of Pearson's correlation or bivariate correlation. And then the last section I've simply described as lots of math, where we're going to be doing many calculations by hand, because SPSS does not do them for us. So first up, bivariate correlation. So this is Pearson's R, and it's the linear relationship between two variables, and we'll revisit all this after the example. The example is unexcused absences and course grade. And you would probably all predict that the more absences you had, especially in an undergraduate class, the lower your course grade. We would describe this as a negative relationship because the variables are changing in opposite direction. So the more absences, the lower your course grade. So one goes up, one goes down. Now often we can make a negative relationship into a positive relationship by just recoding our variables. So if instead of looking at absences we looked at number of classes attended, we would expect a positive relationship. The higher your attendance, the higher your grade. So sometimes the direction isn't that meaningful because it can change depending on how you code your variables. But let's look at this potential negative relationship between absences and course grade. So here are the data, and each circle here represents a single participant. And there's, I'm trying to remember, 87 or 88. That was the number of students in the two sections of my undergraduate motor learning course. So let's just highlight one of these data points, and let's look. Oh, okay, let's look at, say, gotta click on the right tool first. Let's look at this data point right here. So that is one of my students, and they missed looks like maybe 8 classes, and their final grade was a high 70, let's say maybe 77. So all these other points, they represent individual students and their number of absences and their final course grade. And it seems like we have a linear relationship here. Let me clear that. There we go. Okay. It looks like we have some sort of linear relationship here where the students who miss very few classes, they look like they have quite high grades. And then we see the grades slowly decrease as the number of absences increase. So we have a negative slope to our line, so we call that a negative relationship. Do we have a significant relationship? Well, that's where we turn to SPSS and we have it crunch the numbers and tell us whether this relationship is significantly different from zero or no relationship. So in the slides, I show you how to do this in SPSS, but seeing as I'm on a computer, I will open up these data in SPSS and we'll run it ourselves. This data is on Blackboard, so this file is the absences and grade. There'll be a few versions of this as we go through this class. So we're going to say analyze, correlate. We want a bivariate correlation, so that's our Pearson's correlation. Actually, that's one of the options within here. So we'll click on that. Oh, now I ran this a second ago, so these variables are already over there. But normally you would open up and it would give you a list of all the columns in your file. And we want to say, yeah, we want to look at the correlation between absences and the grade. Down here we select the type of bivariate correlation. Typically, and as we'll be talking about, it will be Pearson's correlation. This is a parametric correlation and it has certain assumptions, which we'll get to. Kendall's and Spearman, these correlations are non-parametric correlations. So if you don't meet the requirements of a parametric test, and parametric tests are things like t-tests, ANOVAs, there are non-parametric options. We haven't really discussed those in the course. There are non-parametric examples of t-tests, for example, but for correlation, right here, these are the non-parametric versions of a bivariate correlation. And if you don't meet the assumptions, you could use those. They are typically less powerful tests. So we're going to do Pearson's correlation. We're going to do a two-tailed test. And one last thing in the options, we'll say, oh, sorry, I ran this a moment ago, so you can see I've already checked off here means and standard deviations, just to get some descriptive statistics. And we'll say OK. And the nice, refreshing thing about a correlation, unlike repeated measure ANOVA, where the output just went on and on and on, correlation, it's very contained. So we have our descriptive statistics. We get these because we asked for the means and standard deviations. We can see that the mean course grade was about 81%. I typically have a higher average in my class. Number of absences on average is about 6. And here we can see that the number of data points used in this calculation was 87. Here's the new bit. This is the interesting part. Here we see our correlation. So if we look at this 2x2 table, this first cell is looking at the correlation between absences and absences. Now that data is identical, so it's going to be a perfect correlation. And the correlation, a perfect correlation has a score of 1 or minus 1. We'll talk more about that later. And it's showing us how many participants did it calculate that value on. 87. That's what we expect from our descriptive statistics. So that's not really interesting. What we're interested in is the correlation between absences and grade. And that is shown here. The score, or the Pearson's R value, is negative 0.757. So negative, saying that, hey, there's a negative relationship, and that's what we expected, because we saw that the data had a negative slope. And then the value of that R is 0.757, which tells us something about the strength of that relationship, with negative 1 being a perfect negative relationship and positive 1 being perfect positive linear relationship. Now, is this correlation significantly different from no relationship, specifically a correlation of 0? Yes, because our p-value here is less than or equal to 0.05. In fact, it's so small that we would just simply report it as being less than 0.001. Now down here, we also see a correlation between grade and grade. That gives us a correlation of 1. No surprise. And then this correlation here is a mirror of this other one. So the one in the top right corner was the correlation between absences and grade. The one in the bottom left corner is the correlation between grade and absences. But either way you look at it, it's the same thing, and we're going to have identical results in those two cells. So let's go back to PowerPoint. And I'll just skip through the slides that show that same procedure, but it's there if you need to refer to it. And here at the bottom, the one thing I'll note is this is how you would typically report your correlation, at least the statistics. So I'm saying, okay, the R, so Pearson's R, or the coefficient of determination, equals negative 0.757, and the p-value is less than 0.001. So we have a significant relationship between the number of absences and the grade of the students. So that's the end of part 1. We'll talk more about this in part 2.